Now, when we do digestive tract, I can also use these models. This thing over here would be the parotid gland. It's a salivary gland. For respiratory, I don't have to know it. You don't have to know it. And this is submandibular, underneath the mandible. We'll do that when we do digestive. This is the nasal cavity here. So this is called the external nares. And coming into the nasal cavity, the mucosa has respiratory epithelium. For lecture, the respiratory epithelium is that ciliated pseudostratified columnar cells, interspersed goblet cells. The function of it is to warm, humidify, and filter the air. Sinuses, frontal sinus, sphenoid sinus, they also help with warming, humidifying the air. So there are 3 lateral folds on the wall of the nasal cavity. This is the sphenoid. Up at the top was a cribriform plate and olfactory epithelium for smell. But these are called concha or turbinates, these bumps. Superior, middle, and inferior conchae or turbinates. Between them, here is an inferior meatus, middle and superior meatus. Air that comes through the nares swirls in between the meatus, circular, gives it time to warm, humidify, and filter the air coming in. When it gets to the back, this is the external nares. And from here to here, here's the hard palate, here's the soft palate. At the end of the soft palate, from the internal nares, this is the nasopharynx. So if I point to here, what's this region? Nasopharynx. 2 things are in the nasopharynx. Back against the back wall is pharyngeal tonsils, or adenoids. Over here, this opening is the auditory tube, eustachian tube. Your book says pharyngotympanic tube. I think auditory tube is easier to spell and remember. This equilibrates the air in the middle ear from that of the atmosphere. So as air comes through your nose or your mouth, the pressure can equalize with that of the middle ear. Eustachian tube. If I ask, what's this opening? In this nasopharynx, that's eustachian tube. I go a little lower, this is the oropharynx. The opening to the oropharynx from the mouth is called the fauces. In the oropharynx, you have the lingual tonsils against the tongue and the palatine tonsils just by your soft palate on either side near the palatoglossal arch. So whereas this is respiratory membrane, this is respiratory membrane, over here we have stratified squamous. It goes from the soft palate to the epiglottis. From the epiglottis down to the cricoid cartilage, here's cricoid cartilage back here. This is the laryngopharynx. So food and water go this way, also stratified squamous. And from here, food and water go into the esophagus, which is this little pathway that you can barely see, but it will expand if food goes down there. We're interested in the respiratory tract. That comes forward. So this part is the epiglottis. This over here are your vocal cords. The white, the lower, is the true vocal cords. This is ventricular or false vocal cords. In the front, is the thyroid cartilage. Underneath it is the cricoid part. The thyroid cartilage is a shield. It's only in the front. It doesn't really go to the back. But the cricoid cartilage gets taller in the back. It's a complete ring. If I use this guy, again, for the digestive system, this is the parotid gland. The ear is the otid gland, or otic. So parotid is para-otic, parotid. Then submandibular is underneath the mandible here, and sublingual under the tongue. These are where are they? Here. The inferior, middle, and superior concha with the inferior, middle, and superior meatus. They go into the nasopharynx, the oropharynx, the laryngopharynx. Here's the larynx. These other things we're going to do another day. Here's your thyroid cartilage. Here's your cricoid cartilage. This is your thyroid gland. This is your hyoid bone. Below the cricoid cartilage, this is the trachea. And see the cricoid cartilage gets tall in the back. This piece of cartilage that sits on top of the cricoid cartilage, on the left side and the right side all the muscles are covering it, so you can't see it. But on the left side, you got a pretty good view of it. Whoop, wrong way. What's the number there? Number 4? That's the arytenoid. The arytenoid is what attaches to the vocal cords. 27 the false vocal cords, 28 the true vocal cords. And this thing, 23, that's your epiglottis. So if I leave this closed again, this here is the epiglottis sticking up. And if you look right down the center, this opening, these are the vocal cords on either side. This opening is called the glottis. So this is your glottis. It's between the vocal cords. This is what closes when you start to swallow food and water. And the epiglottis guards it. It's on top of it, epiglottis. So it will close and let food and water slide posteriorly into the esophagus. So you can't swallow and breathe at the same time. While you're swallowing, the glottis closes, the epiglottis comes down, the larynx moves up. You cannot take in air while you're breathing. While you're drinking water or eating. Sometimes we drink and talk too much, food winds up going down what we call the wrong pipe into the trachea. But as I said in class, the idea of waterboarding is having someone tilted back and dripping water on them. They have to keep swallowing the water, they can't breathe. And if they decide to breathe, they allow water to go into their lungs. So it's like drowning. True vocal cords, which has this elastic ligament, gets stretched and looks white. False vocal cords are above it. Epiglottis up here, 23 epiglottis. 27 ventricular vocal cords or folds. 28 is the true vocal cords. Sometimes they call them folds because the respiratory membrane folds over them. So that's the auriculoid, or arytenoid. Number 3 is the corniculate. I'm not going to be as picky as that. I'm not looking for the cuneiform up here or the corniculate. I'm just going to want to know thyroid, cricoid, epiglottis, and arytenoid. Arytenoid comes in pairs. Corniculate and cuneiform come in pairs. So that takes care of the larynx. Those are all the things I can ask you about the larynx. So from the larynx we go into the trachea. That's commonly your windpipe. The muscle in the back is the trachealis. In the front, it has these half rings, like 16, 18 of them, cartilaginous rings, hyaline cartilage. Make sure the airway stays patent, but it's not a complete circle, so it doesn't block the esophagus when you're swallowing food. Let's see which of these models is a good one. Know this for lecture. Being that I'm going to have to think of questions, if I run out of questions, I could use it. This cartoon drawing is of an alveoli. This is where respiration takes place. Bringing air into your lungs from the outside, because the lungs expand, that creates negative pressure. Bringing air down to the lungs is called ventilation. Once we bring the atmospheric air into alveoli, now we get an exchange of gases. That's respiration. 2 different physiological processes must occur for us to oxygenate our blood and to rid our blood of carbon dioxide. Ventilation, we ventilate our lungs. Respiration, in this case, external or pulmonary respiration, where we're taking oxygen from the atmosphere and giving carbon dioxide into the atmosphere. So as we get into the alveoli, there are 3 types of cells, and you have to know this for the test tomorrow anyway. The type 1 cell, the most common cell, simple squamous cell, very thin. This is for respiration, because the content of oxygen, the partial pressure of oxygen in the atmosphere, what was it, something like 165? In the blood, it's like, the venous blood, it's like 45. So gases move from higher concentrations to lower concentrations, but we don't talk of concentrations with gases because they don't have a defined volume. What they do have is a partial pressure. It moves from an area of a higher partial pressure into an area of a lower partial pressure. And they do that by diffusing through squamous epithelium. They share the basement membrane with the squamous epithelium of the capillary. So it makes it very easy. Oxygen goes in, carbon dioxide comes out. Partial pressure of carbon dioxide in the atmosphere was less than a half. No, it was 0.04, way less. So it's maybe like 45 millimeters mercury pressure in the venous blood. So carbon dioxide will come into here. That's pulmonary respiration. Carbon dioxide comes out and oxygen comes in to the bloodstream. So type 1 cell, simple squamous for exchange. Type 2 cells, I think they point them out as the green things here, they make surfactant. Type 2 alveolar cells make surfactant. When we exchange gases, to make it easier, the respiratory membranes start to warm and humidify the oxygen. So there's a lining of like watery substance here. When the diaphragm moves down, the external intercostals move up, the lungs expand, the alveoli get larger, air comes in. When you breathe out, the diaphragm relaxes, the external intercostals relax. Mainly connective tissue in here, elastic connective tissue, so it contracts. When the walls of the alveoli get close together, surface tension from the fluid prevents them from opening up. Surfactant breaks that surface tension. Without it, we can't effectively exchange oxygen. And the third type of cell is a macrophage, or a dust cell. Macrophage to gobble up debris. Oh, that's another point of the lungs.